All right. Good morning, good afternoon, good evening, depending on where you are. Welcome to the kickoff meeting for the North American Regional Team, the Ocean Prediction Decade Collaboration Center. I'm Derek Snowden. I'm the Chief of Operations at the U.S. Integrated Ocean Observing System in NOAA, and I'm honored and happy to be here to help launch this North American Regional Team and have the opportunity to help build this community. I'm looking forward to it. Over the next hour, we'll be discussing the vision for the Ocean Prediction Regional Teams, which will be presented in video form by Enrique Alvarez, the Technical Coordinator of the Ocean Prediction DCC. And then we'll be getting an overview of select activities ongoing in the North American region. The focus of this overview is going to be a subset of U.S. activities. Given the time that we had to pull this together, we felt it best to focus on what we know. And however, my hope is that by the next time we get together, we'll be able to offer a much more complete picture of the breadth of North American activities. So I look forward to further engagements. As we'll hear from Enrique in a second, the goal for the Ocean Prediction DCC is to facilitate collaboration between the decade actions and between ocean prediction efforts within the regions. If we can fully develop these ideas that he'll present, we'll have a powerful structure for collaboration to help develop ocean forecasting at a global level. After Enrique speaks, we'll hear from John Wilkin, who I'll introduce in a second. He'll provide an overview of some ocean prediction efforts in the US. And we should have the opportunity to ask questions using the question function at the bottom right of your screen. So I'll remind you about that a few times over the course of the next hour. But the success of this session is going to depend on your involvement, and so please use that question function. You can either direct them to John or Enrique or to yourselves. I encourage you to have a kind of rhetorical dialogue. The success for this session is going to depend on your contributions to spur the conversation and motivate the team for future activities. Sat through a couple of other regional team sessions this morning, and they really ebbed and flowed depending on the participation of the audience. So I encourage you to stay active and type in the chat as much as you can. There's an orange question mark icon at the lower right, and that's where you can ask your questions. There's also a more informal chat function, but so you can use both, but I encourage you to ask your questions through the question function. After the presentation, we'll have a chance to answer a series of poll questions, and these poll questions are going to be open after the session today. So if you miss one, you'll have time to go back. But those are really important because they're designed to inform the DCC next steps. And so they'll be analyzing that information from your surveys and figuring out how to move forward. Some of the poll questions are focused on assessing interest in participating in a formal role in the regional team going forward. And that can be through leadership of the team, coordination efforts, participating in and moderating online forums and discussions, attending the regional meetings themselves. But these are not firm commitments, right? We're not asking you to sign a contract today. We're only trying to assess whether or not this is the right structure for regional engagement. So please be liberal with your answering other questions. Even if you have some reservations, click yes. We'll follow up on that and tailor this to be most useful to all of us. So I hope this session motivates you and encourages you to participate. And finally, I'd like to offer a special invitation to early career ocean professionals to volunteer for leadership positions. I think this regional team is a great opportunity to learn from some of the leading ocean forecasters in North America and the world. So feel free to jump in and help us make this engagement successful. So without further delay, I'd like to turn it over to the organizing team who will share Enrique's video introduction to the regional team concept.
Hello, everybody. My name is Enrique Alvarez. I am the Technical Coordinator of Ocean Prediction DCC at Mercator Ocean International. And it will be my pleasure today explaining our plans to build our community at Ocean Prediction DCC. So our idea is to build a global and transversal community to promote ocean forecasting worldwide. We are not starting from scratch. We are starting from the success of UNEP regional seas and good regional alliances. So we are taking the best of both worlds. And once all these, once our regions are implemented, will be the backbone to provide a collective voice to a wide ocean prediction community. That means going from coastal to deep sea, going from bio to physics, user to scientist, etc. So we want to identify and attract this wide community in order to support the key action related to ocean forecasting, also to make plans and to develop activities to identify gaps and ways forward, to develop activities for capacity building. For example, if we are able to create one capacity building activity, the regional teams will be the ones in charge of implementing these activities in the different areas, and also for advocate for the implementation of best practices, tools, and standards that we will develop during the decade. We are not doing this in one single step, but we are instead having a step-by-step approach. The first thing we are doing is the kickoff meeting today. So with this kickoff meeting, we are starting the organization and launching the regional teams. This is what all this meeting is about, is just saying hello to the world. Then during 2023, we will be in a second phase for gaining momentum. We will maintain our activities initially through the platform of the event, this Engage platform that we are using for the event. And then once our tool, our webpage is ready and our tools or the associated tools will be ready, then we will move our activities to these new elements, to these new tools, and we will start our cruise phase with this webpage as focal point. We need to find the best organization for our regional teams. So we are sure that we are able to empower these teams to achieve their objectives. In order to do so, we have a draft terms of reference available for discussion. And some of the points we can discuss now is the convenience of having a regional focal point per region to mobilize the activities, and also to have a steering team formed by experts on different topics, all in all regions, the same topics: observation, physics, bio, climate. So at the end of the day, these experts can talk to each other and can create a worldwide network of experts serving the objectives of ocean prediction DCC and promoting the advances in ocean forecasting, especially focused in delivering as one. These terms of reference will be amended and approved democratically at each regional team. So next steps during this 2023 is first this kickoff meeting. This is just knowing each other, saying hello world. Then we will maintain our activity via the event platform. This will last the following months from January to July. Very important, we will have for each regional team a first working meeting, real working meeting that will last several hours for the presentation, initial discussion of the tours, and launching really the regional team. Then once the web page will be ready and associated to it, we will do the migration from the Engage platform, from the event platform to the new event, to the new platform. That will be around July 2023. Then in the second half of the year, we will start working on creating the plans for capacity development and gap detection in every region. And finally, by the end of the year, we will have another meeting per region that will see the approval, the final approval of the terms of reference, and the final approval of the capacity development and gap detection maps. That meeting will take place around November or December. So as conclusions, the regional teams that we are launching with this meeting will be a key element for the success of Ocean Prediction DCC. If we are able to fully develop these ideas, including the steering teams, we will end with a very powerful structure to develop ocean forecasting at a global level. The calendar for 2023 is clear, it's realistic, so let's go. And before I finish, I want to thank you for your time, and don't forget to pin your position on our world map. To do that, you will be provided with a link on the chat. Thank you very much, and let's go.
Thank you. And before I introduce John, I just want to remind you that the polls are open now. They are in the bottom right part of your screen. The icon looks like a bar graph. I think. So please be filling out those during the, oh, they are open. Excellent. So please be filling those out during the talk. John Wilkin is a professor at Rutgers University, the State University of New Jersey, where he teaches undergraduate and graduate courses on the dynamics of marine ecosystems, satellite remote sensing, and data analysis and simulation of the coastal ocean and adjacent deep sea. His research work focuses on applied ocean observing and forecasting, merging high-performance computer simulations with observations from satellites, underwater robotic vehicles, animal tags, and other novel platforms. The ocean forecast systems he develops are applied to understanding how ocean dynamics affect marine ecosystems and to deliver actionable guidance for marine operations and environmental health. Importantly, John co-authored the National Strategy for Coastal Ocean Modeling in response to a 2013 US Presidential National Ocean Policy request. He's past co-chair of the UNESCO GOOS panel on ocean observations and physics for physics and climate, and participates in international schools training early career scientists on developments in observing and modeling the marine environment. So thanks for being here, John. Take it away.
Okay, thank you, Derek. Okay, so kickoff meeting. I can't help thinking, if it's kickoff meeting, thinking about rugby. So it's in my DNA. So there's a picture up there of the great Dan Carter, all-time highest points scorer in Test rugby. Okay, so as Derek sort of prefaced in his original introductory remarks to the session, I'm going to talk about United States ocean modeling for operational prediction. I'm sorry, it's not going to be a pan-regional North America survey as you would have liked, but as Derek said, in the time we had to put this together, we're just going to focus on what we know. But hopefully I can touch on a lot of the issues that are relevant to the entire region by sort of showing some examples of what we're doing. Okay, so real-time operational ocean prediction. So real-time is meaning the ability for users to see, analyze, and evaluate data as soon as it appears. And so kind of sort of a trivial example here, we've got some detailed information coming in, these birds flocking, and then those observations go into some processing system that we have to reduce that down to some particular information product that's relevant to some stakeholder. So here, real-time edge detection. So we want to count up how many birds are in the scene. In regional ocean modeling systems, we are typically simulating temperature, salinity, velocity, so ocean physics, and that is information that informs ocean dynamics, geomorphology, biogeochemistry, and ecosystems. So that's regional modeling. And when we operate models in real time to produce nowcasts and forecasts, we're aiming to come up with actionable guidance, information that can assist decision makers on aspects of the environment. Now, traditionally, in the United States, the federal agencies like NOAA and other state agencies have been responsible for implementing very robust, reliable, always up operational forecast systems. And the academic institutions have tended to focus on process studies and model development. But increasingly over the last, actually, I would say decade now, academic and research groups have been running sustained regional forecasting systems that are almost as robust and up and delivering information on a similar sort of schedule to the national centers like NOAA. And this has largely been done, and I'll say a little bit more about US IUS and the regional associations. But the motivation for doing this is that with local knowledge, often local modelers can come up with a more skillful configuration. They may have access to real-time data sets that are not in the operational data stream, so they can assimilate more data, constrain things better. They might be able to run at higher resolution because they're looking at a limited area, and they know who their stakeholders are, and they can produce specialist products to match that. And so what we're seeing is that user communities throughout the United States have been finding these systems operating in academia and non-governmental research to be valuable. So in the top graphic up here, the regional associations of US IUS, I'm associated with Maracus in the Middle Atlantic region, and they're both coastal United States, but also PAC-IU Pacific has responsibilities throughout Pacific territories of the United States and the Pacific Ocean. The National Ocean Service itself, shown in the bottom right graphic, have a number of operational systems. They're the green boxes that are outlined here. Mostly they focus on ports, estuaries, and coasts, but recently have branched out to a pan-regional West Coast ocean forecasting system, WCOFS, here that covers the entire East Coast. There are other global systems I'm not going to talk about. There are global systems within NOAA using High Common RTOFs, ECHO, and the Storm Surge STOFs system. So if you go to the OOFS Hall of Fame, you can look at some of these presentations. I hope these people, some of these people are going to be in the session today and contribute to the conversation. There is a talk by Caleb Dean on those operational forecast systems that NOS operates, and more about the storm surge. And then if we go to the regional associations, and so what those systems produce, here's an example of the Chesapeake Bay model. This is CBOFS, Chesapeake Bay Operational Forecast System. And on our website, you can go to a map server and click on any one of these stations, and you can get forecast information, sea level, temperature, etc. There's another system for the Delaware Bay that complements that. And so these are, at different locations kind of spread around North America, United States. The West Coast has a full regional model. I'll say a little bit more about the future of East Coast forecasting as we go. There's another 4 sessions that are there. I hope these people are going to be on board in the discussion. And, this is sort of a way in which partnerships between academia and the federal government are driving innovation. So for examples, Live Ocean here Northwest has emphasis on ocean acidification prediction, but also has been used for climate change scenarios and are pioneering cloud computing. And you see Santa Cruz, variational data assimilation from Chris Edwards, and that system is also coupled with a biogeochemical model. On the Texas-Louisiana shelf, there's a strong interface in this modeling system with the National Water Model, so from hydrology, some novel techniques in automation of the system, and NECOFS in the Northeast region, which overlaps with my own Maracus region. There's a strong history of unstructured grid modeling and coupled modeling, including waves and weather. So very different modeling systems, all pushing the innovation sort of envelope. This work is largely facilitated by support from NOAA for systems that are running in real time, perhaps not exactly operational. And that's through different mechanisms like the Coastal Ocean Modeling Testbed, Ocean Technology Transfer Program, various other projects supported by National Ocean Partnership Program. And there are these regional, I would say sort of frameworks, not regional, development frameworks that I'll mention very briefly, UFS JEDI and NUOPSI. So just a little on my own work in the Northeast. So we have a system that you can sort of see the modeling region here. It's a very data dense region. We've got an extensive HF radar network giving surface velocities, real-time telemetering buoys in the Gulf of Maine. And until recently, the NSF Pioneer Coastal Array, a network of profiling moorings and a supporting glider fleet in this region of the Middle Atlantic Bight. That array is in the process of being redeployed to the southern Middle Atlantic Bight. Will be rolled out in the next couple of years in a similar sort of format to UC with a different arrangement. So we've got lots of data to work with. In the system that I run for Maracus, we are using 4D VAR data assimilation to incorporate all of these observations. Infrared and microwaves SST from satellites, all of the altimeters that are on orbit, any in situ observations that go to the GTS, surface currents from the HF radar that I mentioned, and autonomous vehicles, gliders, deployed by Maracus and the NSF. And most recently, we've added to our input data streams real-time bottom temperature observations from sensors that are on the Northeast Fishing Fleet trawls. We get about 300 observations a week with bottom temperature. Incredibly useful, valuable information to add to the data stream. Just one example of model performance. Here we've compared to global products, to Mercator Océan, NRL HICOM, their GOFS model, and one of our own models without data assimilation. And I'll just point here, looking at squared coherence in sea level. The blue line, which is our data assimilating downscaling regional system, we achieve significantly better coherence in coastal sea level prediction across all timescales, from interannual here, 10 years to 10 hours. And so this is demonstrating the value of both downscaling from global systems, because if we didn't gain any skill by downscaling, we might as well just take the Mercator forecast, right? But we don't. And by also working on our regional data assimilation configuration, we further increase the skill. So we've got a skillful system for sea level analysis and prediction along our coastal region. And if we just look at these scatter diagrams here of model on the x-axis and observations on the y-axis, our data assimilation system here, this is for these sensors that are on a trawler, little probe that's attached there. You can see the distribution of observations over a couple of years of data throughout our region. And because we've collapsed the scatter, these data were not assimilated in this, but the skillful, but now in the real-time system, they are. So that's what we've been doing. And now other developments to where I think coastal operational forecasting can go is in very high resolution nested data assimilation. Here we're doing this for that OI Pioneer Array region, because we've got a lot of dense observations from gliders, the little colored tracks here, and the moorings, the triangles. But one might think of doing this operationally for ports or estuaries to get added resolution where stakeholders in Chesapeake Bay, for example, need that enhanced resolution. So the comparison here between these two observations and model shows you that we are able to get analyses at the sub-mesoscale when we have dense observations to support that. Now, in terms of collaborative developer frameworks, I want to mention three things that are very active within the US modeling community. JEDI, Joint Effort for Data Assimilation Integration, is sort of a object-oriented interface for building data assimilation systems where everything is broken into its component parts, so you can interchange the ocean model or the atmospheric model. There is an interface to observations, different observation operator types, and then drivers for ensemble data assimilation or variational data assimilation. We could even be merging the tangent linear and adjoint models from the ROMS 40VAR system with, say, MOM6 as the forecast model. So we can switch components in and out. And this strategy, this commitment to data assimilation with JEDI is underpinning a lot of development within the National Weather Service and the National Ocean Service. For Earth System Model Coupling, there's NUOPSI, the National Unified Operational Prediction capability built on the ESMF toolbox. And this again is an object-oriented interface where different models can be switched in and out, and through standard interfaces for exchanging information, you can couple a different atmospheric model with a different ocean model and a wave model. So NOAA and the US Department of Defense and the Department of Energy are committing to using NUOPSI as their coupling interface. So we're trying to grow the community of models that are inside, that are using NUOPSI. And one framework for that is the Unified Forecast System here, the UFS, where different model code sets are being managed within UFS. These coupling interfaces are being managed within UFS, and they are trying to work on capacity development by having easy to follow graduate student test cases for different modeling systems. And the idea being that this unified forecast system will be covering the whole spectrum of both weather and subseasonal to seasonal prediction, climate prediction, and also in the coasts. So I mentioned that there's a West Coast WCOFS system in operations in the National Ocean Service. We have, I'm leading a group now that is looking at establishing a similar system, complementary system, also based on ROMS 40VAR assimilation for the East Coast, that we're at the moment calling the East Coast Community Ocean Forecast System. And this is just one vision for how it might be. This is not how it's necessarily going to play out, but we've got a regional ocean domain here up in the top right, and the white box in the outline there would be the domain of an atmospheric model that might be coupled to that. Here I'm indicating that we would use FV3, which is the Weather Service's new forecast model that underpins the GFS forecast. But these things are all to be decided. So we're already making progress on data assimilation and improvements upon the Mercator Ocean initial solution here with our own. Here in the third column, we can see that the difference from observations has been driven down by our regional data assimilation methodology. Another framework of interest is this NOP project led by Maitane Albarrieta at the University of Florida, which is a real-time system. So there's a level 0 grid here that runs operationally in AWS Cloud. There are a number of pre-configured nested grids that are all set up that where boundary conditions can be generated swiftly for those, and those models can be run. And then depending on a forecast hurricane landfall in one of those regions. And then on the fly, those models can be further refined as predicted landfall track for a hurricane emerges down to the 1 kilometer, 200 meter, or even 5 to 20 meter resolution. And these models are generated quickly, pulling databases of bathymetry, vegetation, in order to look at impact right at landfall in terms of sediment disturbance, forces on structures. So this is a very ambitious project that is in action now and was generating forecasts in the last Atlantic hurricane season. So I think some great sort of new things coming out from that group, and generic tools that are being made available through GitHub community exchanges. So coming to sort of wrapping this up with some of the issues that I hope will generate some discussion here. I'm sort of posing the question, well, you know, how can the modeling research community assist with throughout North America, and I hope we can move beyond my limited US focus here, in supporting future operational system development. I mean, this is what the this ocean prediction exercise is all about. I think we have a lot of consensus on what the science challenges are and what we need to work on. That comes out of the IOCI's task team that Derek mentioned that I co-chaired with Leslie Rosenfeld and led to this paper in Journal of Operational Oceanography about what a modeling strategy should be and what methods we might use to promote that. A follow-up workshop some years later in North Carolina, led by Oliver Fringer, led to another publication which echoed some of the recommendations, but it was more on the science and less on the process. So these are the things that I think that we need to work on. And how do we do this? So I'm going to throw some ideas out. Hopefully this will generate some discussion for the other half of the session. I would say the academic community and our federal partners also are already pretty good about embracing standards. And so model agnostic approaches to data access, FAIR principles, data formats. We've got a good Earth system modeling component coupling network with NUOPC. We have the JEDI framework for data assimilation. And these are all collaborative open source systems that are generating a lot of rapid development. So that's great. What I think we need to work on is incorporating more regional models into that unified forecast system as one way of making modeling setups for different regions open to a broader community of users to experiment with. So that it isn't just me and my team at Rutgers University that are experimenting with our Northeast model. If someone else wants to get in there, they've got an idea for ensemble data assimilation that might be better than our 40VAR, they could easily have access to that and experiment with that. And IUS have created a cloud computing sandbox that I think is one possible avenue to do that. And one of the impediments we have is that UFS is very US focused. It's not pan North American. So we might have to think in this community about how we make make that more inclusive. My vision for an East Coast forecasting system, you will notice, goes from Canada to the Orinoco River. So it's including the entire North American, Central America coastal region on the east. Getting access or looking at some of these federal model operational systems, they can be difficult to emulate because they're not well documented. We know they run inside the firewall at INCEP operations, and academic community can't get in there and experiment with duplicates of that. So we need to work on that, and we need to get better access, I think, to the forecasts. I think we're well behind the level of service that's delivered by Copernicus, for example. How might we do this? I've been pushing this idea for a long time. I think as regional modelers, we need to get together in a caucus and discuss these things to foster intellectual exchange, get our best practices out there. And there are lots of mechanisms within the UN Ocean Decade Framework, Ocean Best Practices, that I think we should be looking at to leverage to accomplish this. As I mentioned, greater access to those federal backbone systems. And as a community, we could promote themed publications, our own focused workshops for early career professionals, or even older ones like me that are still trying to learn things like Python. And it would be a community that's doing and not talking. That's sort of my vision there. So not so much conclusions, but what I would say in terms of recommendations, just to repeat those, is I think we want to expand our nation-focused frameworks like NOAA to be more pan-regional, North America. So I agree with your vision there, Enrique. We should definitely be building on existing networks that we have, like Ocean Predict. A number of you, I think, are involved with Coast Predict, another UN Decade endorsed program. And beyond IUS, we've got Ocean Networks Canada, CEOS, and various other activities in Central America and the Caribbean. It's going to be different ocean models of all different types. We should remain model agnostic, and I hope that we can, through this initiative that we're convening here today, grow a North American regional modelers and model users community. And I'm just repeating the things I said in the previous slide. Foster greater intellectual exchange between these groups and best practices. Perhaps work towards pan-regional data portals, so they're not just focused on IUS data streams, but everything coming from the Canadians and our Central American colleagues. And again, focused workshops that encompass and bring in everybody in the region to do some doing and less talking. And so with that, I will stop with the talking. And now I think I am handing back to you, Derek. Just for the people that are listening, I can't see what you see through the portal at the moment. So if you're asking questions there, they're going to come to me through a different avenue. Anyway, that's it. Over to you, Derek.
Yes, I'm off mute. Thank you, John. There are a couple of questions, and I'd like to encourage everyone to keep those coming. Those are really important. So maybe we start with this before we move into the polls. And the first question there you can read is concerning the other Ocean Decade projects, and I think Enrique might be best positioned to tackle this one.
Thank you, Derek. Yes, I think in good position to reply to this one. And if you were not able to stay on the sessions yesterday, it's important that you understand the position of the Ocean Prediction Decade Collaborative Center in the framework of the decade. The Decade Collaborative Centers, because there's not only the Ocean Prediction one, there will be other ones, are in charge of, are called transversal coordination units. So our role is to make sure that the different programs talk to each other and create coordinated effort, that there is not significant overlap, that there is not people repeating the same things, and that at the end of the decade, the products that are created make sense and will survive the decade. This is the whole idea about the Decade Collaborative Centers. So we are in charge of somehow soft coordinating the programs, and you know that the projects depends on the program. So this particular project that you are mentioning, for sure, it's in the framework of one program. So all the programs will have a direct attachment to one of the Decade Collaborative Centers. In our case, for example, we have a direct attachment with 4C, which is the program that is linked to Ocean Predict. So in fact, we are now making a lot of plans of working together, and we are looking how to promote 4C And one of the things we are going to do is very much linked with what was John explaining on the very last slides. We are going to create, together with FORESEE, what we will call an ocean forecasting co-design team. And we will look in this co-design team on which are the best ways. We will trace a roadmap for the decade in order we can facilitate that the different countries of the world can deliver as one. And all the experience that you have been gaining on the States at national level with things like such as JEDI, I think we cannot look to other places, and we have to incorporate all this experience in this ocean forecasting co-design team. So this is something I want to talk with you guys on the following weeks, because it's very important that this is not a bias from one continent. For me, the natural bias will be to Europe, because it's where I have most of my scientific contacts, but it will be important to incorporate the experience from the different continents, and North America is critical because you are demonstrating it, because you are already on this track.
All right, thank you. I see the questions are flowing in there, so maybe we can take a couple more before we switch to the poll. We've got some time at the end for discussion, and maybe we can just absorb some of that now. That second question about co-design, you hinted at it, Enrique, with the co-design with the team that you're talking about standing up. John might have some thoughts. I can also comment on some of our activities there, but it seems like that's a rich area of activity right now. There is the Ocean Decade Co-Design Team, or Co-Design Project, right? Ocean Observations Co-Design, which we heard a little bit about yesterday. And then John represents one of the IU's regions. So what are your thoughts, John?
Yes, so this might be a rather specific response that's, again, US focused, but through our network of regional associations that I showed in one of those introductory slides, the different ocean observing systems, we have groups that are continuously engaging with our perceived stakeholders through that process. So when I want to get some input on, hey, who's interested in an East Coast ocean forecasting system, I can actually go to the directors of those regional associations and say, you know, hey, what's your network? What can you tell me about how we should be designing this? Are we designing for the offshore wind people? Are we designing it for fisheries? Whatever. And so those networks exist. And if we wanted to have some workshop on, you know, future stakeholders for an East Coast forecast system, I would know where to start with inviting people like that. And so I think the lesson there, the larger lesson, is that it's good to have a network of people who are regularly communicating with stakeholders in different sort of realms and frameworks, and work that network. So as an ocean modeler, you know, I'm not going to go down to the docks and start talking to fishers about what they might need from an ocean forecast system. You know, we've got people who are already working that relationship, and I'm sure that that's generally the case across many of our regions and our working communities. So that would be my response, is to work the networks that we have rather than build something new.
Right, I appreciate that, John. As I mentioned, I'm also from the IU's program, so I have some familiarity with that. And I think within NOAA, we also have what we call the service delivery framework, which is a concept for how to do this well. But I think one of the little secrets there is that we're not well practiced at doing it. And so taking the interactions that John described through the IU's regions and asking how might that work within the National Weather Service or the National Marine Fisheries Service, which are other parts of NOAA. Everyone has different ideas. So that's one of the things that this Ocean Decade effort might help us with, is taking success stories within small programs and making them a little bit more applicable to a larger audience. So it's something to think about. We're moving along on time, and I was just reminded that we will answer all of these questions in written form on the website after the session. So if we don't get to every one of your questions, we will do our best to offer a written answer. Maybe that last one on AI, John, I suspect that's a fairly easier one to answer. Do you have any AI-based solutions for data assimilation?
It's a really interesting question. It's been coming up a lot. National Ocean Partnership Program, NOP, recently had a call for proposals, specifically targeting AI developments in ocean prediction. I assume some groups were funded under that. I don't know exactly what progress there has been. I do know that within the JEDI community, through involvement in one of the projects I have, that machine learning approaches are being used to model background error covariances in data assimilation systems. So, which is one of the vexing problems of how do we understand what those intrinsic errors are in the forecast system, so that we can weight them appropriately in data assimilation systems, and machine learning is proving to be an interesting way to do that. So I've certainly seen that there is activity in the meteorological community in that, and it's starting to spill over into ocean modeling at the large scale, basin scale. And this just points out why a framework like JEDI is really a great development tool, because the people who are doing this are working within an object-oriented system with agreed interfaces to exchange information between component models. So if I make my modeling system compliant with the JEDI protocols, I immediately have access to the work that someone else has done to set up an AI-based or machine learning-based component. Similarly, that's how we're generating our ensembles for ensemble prediction. We don't have to write that code anew. We're repurposing generic codes that have been built into the JEDI system. So that's all I can offer in terms of my own knowledge about where these things are going. But I think it is a rich landscape for modeling development for sure.
All right, thank you. And the final question there, fairly specific one. Maybe I'll take a stab at that. Sarah, I would love to follow up on that question. I think that your observation that it's mostly listening and learning at the beginning might be accurate. I think we're at a point of, John mentioned that he's not going to be the one to go down to the docks. I agree with that. I think that's where his time is best spent, but it's really difficult to figure out how to translate that information for the people who are going down to the docks to somebody like John, who's developing the next generation of models. So I hope that's an emphasis of the DCC. I know it's something that concerns our program individually and NOAA collectively, but I'd love to see how we can address that more broadly through this collaboration. So with that, let's move on to the survey questions and see what that generates. Pretty rich set of responses here. Main needs associated with ocean forecasting. Interesting that capacity development is the largest one. I'm not sure what that means in terms of how the word cloud is created, but hopefully that's the most important response. John, do you have any thoughts on capacity development? You mentioned workshops in your opening remarks.
Well, yeah, so I'm involved with one of the other UN Decade projects, Coast Predict. And so coastpredict.org, I would encourage people to go and check that out and possibly become involved. There are activities there to do with co-design and development of regional downscaling forecast systems. And there's a focus area 6, which I'm chairing, on capacity development. So the conversation there has been where we're going to take this is that we will be suggesting to the UN Decade, collaborating with groups like 4C that Enrique mentioned, which is a capacity development initiative in Ocean Predict at the global scale. We want to motivate similar efforts in the coastal scale, the coastal observing and modeling of prediction. A major plank to that is summer schools for training. We have formulated a prospectus with the idea built on a summer school model led by Brian Arbick from the University of Michigan, called COESSING, COESSING, Coastal Ocean something or other in Ghana and Nigeria. He's been running a summer school in Africa for the last 4 or 5 years, which last year in person had nearly, I think, over 100 students from Central West Africa that participated in some hands-on learning about ocean observing, but also modeling and development. And so I think that's a really good template, a model for summer schools. So our vision is to kind of modularize that into sort of plug and play solutions for anyone that wants to run a summer school in wherever. We would have lesson plans and software, repositories ready to go, some pre-recorded lectures, but also a large network of people that are interested in doing this. And through another UN Decade endorsed program is Ocean Corps, CORPS, kind of like Peace Corps, but for oceanography. Brian Arbick is the leader of that, and the Ocean Corps community is definitely promoting this idea for pushing out summer schools to regions. The vision is maybe 20 summer schools per year in 4 different continents, 5 different regions, and there's no shortage of people signing up for Ocean Corps who want to serve as instructors and teachers. And if you're interested in that, I would encourage you to look into Ocean Corps as a participant. It's international as a part of the UN Decade framework. And other things that the Coast Predict capacity development wants to bring to that is resourcing it. So making sure that we have cloud computing resources for that summer school, so that people can spin up their Jupyter Notebook or whatever and run some of these ocean models, which they don't have access to computing resources in Ghana or Nigeria for, right? We still have to grapple with internet connectivity for that. In terms of learning how to make observations in the coastal ocean, I want to see us generating a pool of appropriate technology instrumentation. So the sorts of temperature sensors, like I showed, we are getting data from the fishing fleet. We could start putting sensors like that on fishing boats sailing out of Ghana, for example, or whatever ports, and bringing those data into the data streams that would inform coastal and regional models, globally throughout the global coastal ocean. But that needs to be resourced, right? And we want to present sort of, as I said, plug and play templates for, you want some pressure gauges for sea level, you want some temperature sensors, this is, where you would go to buy them, or maybe we can motivate, foundations that are active in particular areas to resource that. So that's the Coast Predict version for driving capacity development, summer schools, online learning materials, and just engaging a lot more people in that education process. And it could be you start out at a summer school, it really works for you, and then that opens an opportunity to come and work with me at Rutgers on coastal modeling, for example, so that we can start a stream of people to get their training and education locally in their home country first, but they also open doors to international summer schools, or a split degree. You do 6 months of your research work in the United States or in Toulouse, and you finish up your degree back in Ghana or Malaysia or wherever you're traveling from. So thanks for that interest by the community on capacity development. It's definitely a theme that's coming up throughout the Ocean Decade.
Sounds like there's a lot of progress already, so thank you. Can we, I think we should move on to the next question since we're running a bit behind. Are you using any existing services? I think we here in the US look with some envy at the Copernicus system, but it's nice to see NOAA is actually a well-used system here in the US. So I appreciate that. Any observations here? Coastwatch is a particular program within NOAA, but I see CMEMS more than once. Canadian IUs is nice to see them show up there too. That's great. I didn't have any particular observations on this slide. Unless, John, you want to jump in, we can move on to the next one. All right. How are we doing so far? Is ocean forecasting providing the solution to needs? This is consistent with some of the other regional sessions that I've sat in, is that the overwhelming answer is partially indicating we've got a lot of work to do, or there's a lot of opportunities for improvement. So that's good. This is also the fact that we are providing a solution today. The number of yes votes is a little higher than I've seen in other ones. So that's encouraging. 0 no votes. So that's, that's also encouraging. Let's move on, please. All right, here's where we can see the opportunities. What are the major gaps and deficiencies of ocean forecasting in our region? The first slide that we moved past a little quickly after the capacity development had a lot of data comments on there. I was actually curious if we'd see more mentions of observations here. But what are your thoughts here, John? Is data the big open question?
I think those are all legitimate issues and equally weighted as they appear to be in the word cloud. So
yeah. Co-design for informing local priorities. That's the.
And this,
you know,
these issues are true even in North America, which is an extremely well observed region with a lot of capacity. And if you go looking for observations in coastal Africa or parts of Southeast Asia, there's almost nothing. So this is why Coast Predict is so desperate to grow capacity in the global coastal ocean and get even basic instrumentation into people's hands so that we can improve the available reliable data and follow best practices to make sure that those data are curated and quality controlled and transmitted out to the whole community.
Excellent. This is something that I hope that Ocean Prediction DCC can help with. I've personally been involved in data dissemination for 15 or 20 years, and we've made a lot of progress, and yet we still hear a lot of the same criticisms and gaps in terms of lack of accessibility, discoverability, and that sort of thing. So it would be my hope that this group could help kind of shine a light on more specifics about just exactly what the issues are that we still haven't quite solved yet. Because like I said, we've come a long way from the 1990s, but we still haven't quite solved it yet. So next slide. This one's, if I had to pick what I wanted to be the answer to this question, that would have been it. So I'm glad to see that. What are the most demanded and urgent developments required in your region? So regional downscaling is the overwhelming winner. I hope there's a good sample size here. John, you mentioned high resolution nests in your comment. I guess that's one in your presentation. I guess that's one way to do downscaling, but do you have any thoughts on what exactly the most urgent development is around downscaling?
Yeah, it's front and center now in our mind at the moment as we think about this East Coast Ocean Forecast System. But I think that NOP project that Maitane Albarrieta is leading is a really interesting approach to that, which is to have a core regional model that always runs, and then have sort of some predetermined nests already configured. You don't necessarily have to run them all the time, but if a use case pops up, and of course that project is directed at hurricane landfall events, so extreme weather. But looking at what's going on in California at the moment, right, with the whole port of Santa Cruz getting completely beaten up, perhaps greater actionable guidance from a forecast system that could be spun up on demand would have been useful in that situation. It would be interesting to sort of go back and revisit that scenario in people's minds. So if you want to do this, and we're talking here about operational forecasting, of course, in this framework, is you don't have all the time in the world to sit there and write the code that's going to do that. You've got to have it ready to go. You've got to have these systems in place, and that NOP project is very mindful of that. We have a code base that's generating the boundary conditions for those nested models to set them up. And then, but once you get down to landfall and impacts, and you have to start interrogating databases of vegetation, because we're talking about coastal inundation. This is where the land now becomes the ocean. those are quite challenging, but there are very good databases available to us in North America for that sort of work. Not the case elsewhere. So I think to take it to that extreme for storm impacts, for example, there's work that can be done perhaps on the remote sensing side to characterize coastal environments globally using historical Landsat data or new data from the Sentinels and other missions in a way that is creating the database that's necessary for someone who's writing an automated system to do regional downscaling. I think that would be a really exciting project. So there you go. There's your next funding announcement. It's coming out of IUS or NASA or NSF or European Space Agency. There's some. I see fantastic applications in Sentinel Hub, where people are taking Sentinel environmental data and using it for this sort of characterization globally. So bringing that community together with the regional modeling community, that could be something that that this initiative could focus on. Put that on your list, Enrique.
Regarding the nesting question, I look forward to learning from some of the other operational agencies around the world who have had success here. I know that within NOAA, this nesting is as much a system engineering problem as it is a science problem, and just figuring out how to get it all to work within the operational constraints. So I hope we can learn from successful applications. Let's move on so that we can get to the requests for your participation. Here we go, again, a fairly equally weighted set of responses that look like they span a lot of, there's another regional downscaling, but I'm seeing a lot of threads of connecting to the end user and understanding socioeconomic connections, urban planning, decision-making, that sort of thing. So hopefully that's helpful to the Ocean Predict team. Let's move on one more so that we can wrap up and get people back to their day jobs. Now, as a reminder, this is a hypothesis that the Ocean Prediction team has put forward, that the regional teams are a useful construct for collaboration. You are not signing up to lead the team today. So please continue to respond to this question. This is a similar response to the other two sessions that I sat in at. The job opportunities was the largest response. So people are interested, hopefully, in both obtaining new jobs, but also offering new opportunities. I know that we're struggling to find talent in some areas within NOAA in this area, but otherwise fairly even distribution across just general forecasting news, staying abreast of ocean decade activities, capacity building shows up again, some interest in artificial intelligence. So this one looks like probably needs some more respondents to get a solid understanding, but it's a good survey. Next one. Would you be interested in participating? I understand we don't have a lot of biogeochemists in the room, and perhaps no one interested in being a secretariat, but other than that, some modest interests in the rest of the topics there. So we're coming close to the end of the session. Are there any more questions that we want to review for the group? Yeah. All right. I think we're done. So in closing, I just wanted to thank you all for your attention and participation today. I look forward to working with you as this activity grows. I hope that it does grow. I think it's important and will be rewarding for all of us. The poll questions will be open for a period of time after the meeting. So if you haven't answered them, you still have time, and your answers are really helpful in guiding the evolution of the DCC. And all of the other questions that came in through chat or other forums that haven't been answered, like I said, we'll try to answer and have posted on the new website that Enrique mentioned. Is there any final remarks that you want to have, Enrique?
Yeah, thank you very much. I think this was a very fruitful session, even if we had not all the time that we wanted to prepare, as you said, with different actors from other countries, but there are very important connection points that we need to explore, and if we don't explore those, we are not going to have a successful DCC. I can see these activities on JEDI about being model agnostic are extremely linked to our plans for ocean forecasting co-design team, and also what John was mentioning on with respect to capacity building is very important, because this is one of the requests by IOC that we are dealing with capacity building activities. This is in the mandate that we have. So we have to coordinate with COSPEDIC there, and we have to coordinate with you there in our role of Decade Collaborative Center. As I explained it, this is a role of coordination and collaboration, soft coordination and collaboration. And in this sense, I want to close by inviting you to go into the platform, and if there is this need of capacity development, please specify in the EDA labs, what are your ideas? What are you missing with respect to capacity development? If you believe you are missing specific information in downstreaming, in downscaling, please specify this in the EDA labs, that or whatever idea, doesn't matter if it is crazy or not. Finally, to finish, I want to ask you to, once this meeting is finished, let's go to the Antarctic session. There's another session running on the Antarctic, and let's be participative there in order to promote this session also. And it will be also a very nice way to finish our day. It has been, I can promise, a long day with sessions for 12 hours, one after another, and we will really enjoy finishing on the cool place, which is Antarctic. So, Derek, the floor is yours again to close.
Oh, I think you said it well. I want to hurry up and give people a chance to get over to that other session. And thank you very much. I look forward to continuing to engage in this work. And hopefully the next time we're together, I can actually see you, because the only people I see are John and Enrique. So it'd be nice to be in the same room with a lot of you. Take care.